for the reminder.
Yeah. So as an engineer, I get excited almost every week. We find new toys to play with, especially in this AI era, and then that's like it's exponential, right? Like unlike earlier, eh, and also it feels like they got upgraded in terms of unlike the regular CRUD software applications, all those. I was born in an era where we were learning about struts and Spring Framework and all this. Like, it just seems so boring now thinking about those. And we are in this agent era. And today I'm going to talk about some interesting topics and topics which are very relevant to today's technology and especially Salesforce. We being the pioneer in AI, there's so many concepts which are being kind of, you would probably say if you're following AI Club or some other channels, things are getting flooded with things about MCP and agents, multi-agents, etc. So today, obviously, I can't teach you something in 1 hour. But what I would attempt is to probably talk about show a paved path that I have gone through and share the fun I had, using these tools. And especially for me, it's important that we learn the fundamental concepts, the first principles of what are things made of, rather than focusing on the exact one framework or one tool or the other, because as you know, tools keep evolving. One gets outdated immediately in a week, right, these days. So let's understand the first principles, and let's also kind of see with examples, right, that's how we can easily learn. So I'll be showing multiple examples throughout this talk. At the same time, it's in the end, it's not about understanding code in the talk in 1 hour. Like I said, maybe even if I show you code, I'll probably talk about it. Since it's being recorded, you can always go back, but I'll also cite you to the resources where you can find those, and then play around, play with them yourself, so that you get more insights. So that's what the kind of I'll kind of try to now jump into the talk. So okay. So what's on the menu today? We're going to start with why does it even exist? Why and what is MCP? And the core concepts and architectures. And again, given we have a wide spectrum of audience, I'm going to go start with the basics. But that said, we will build up to the advanced parts of it. But like I said, I'll be citing you to the right resources where you can explore more, rather than we having this session like a training session. It's just a tech talk. So, and then key features and specifications of and what makes it special, and the ecosystem, and what's out in the community, and how we can kind of leverage, learn from the existing things out there, and then find the right tools to get the job done. And then we'll also then discuss about the building blocks of an agentic workflow, and how what is MCP? MCP is just a part in an agentic workflow. We'll see the bigger picture, and then we'll also have some fun examples across. So the starting of the why part, why the why problem MCP solves is the M-into-N integration problem. Of course, it's a classic problem, maybe across industry in almost every domain. And the one that they're tackling here is like LLM apps can be many. There can be multiple LLMs, and there are multiple resources like the traditional ones like the database, APIs, and etc. But there is no one standard how an LLM talks to an external resource today. OpenAI had their own, and maybe others have their own ways of doing it, and developers find it frictionful, kind of writing these custom built bespoke connectors. So that's where Anthropic came in to solve the problems of developer friction. And now it's like the database is no more a database, and you kind of dress it up with this MCP, and now it suddenly all of a sudden becomes LLM friendly. And now this is agnostic, LLM agnostic, and no vendor lock-in. And then you can interop with multiple LLM apps as well as LLMs. So that's, I always spoke about how it standardizes. I will talk about the protocols and all going forward. but I hope you got the core concept of what is an MCP. And because of this nature, because it treats everything like a tool, I'll get into what is a tool and all. You get to orchestrate and then build complex agents because of this. Think about the power of making it a generalized. Again, they compare it with USB-C port for your laptop. They can plug your hard disk and plug your mouse. It's been a while I've plugged a mouse to it, but yeah, you can plug in a lot of things to your USB-C. That's how you can think of your laptop as the LLM brain. Now you can plug these multiple tools in a universal way. And then, of course, there are a lot of pre-built integrations. A lot of them are being driven by the community itself, and you keep seeing a lot of buzz across multiple companies kind of officially releasing their MCP servers. That's the best part of it, that you don't have to really, as a developer, start writing when you have to integrate. Things are out there like plugins, right? There's no official marketplace though, but I'll show you where you can find a lot of awesome servers. And MCP architecture, the best part I love about it is very simple and elegant, right? That's the part that makes it easy to understand and implement. So it has mainly three parts: hosts, clients, and servers. I'll just quickly go to their website so to show you the diagram. So when I call a host is the LLM, and the client is the one which is the middleman between the LLM and your server. So most of the times, I think if you've already started using Cursor, host and client, like I mean, from an end user, they look as if they're in the same tool, although they're placed differently. But most likely, they come bundled, like Cloud Desktop or Cursor, or there are different tools out there. Now, how does your LLM? Now, how do you connect your LLM to something that's running on local host or somewhere outside? Right, that's where the protocol comes in. So these are the servers. So servers, maybe like I said, it can be in a computer or remote. And the servers internally, they're like the portals to talk to your the old plain old databases and the file systems and whatnot. So that is as simple as that. I mean, if you're thinking like you may be missing something, it's oversimplified. No, it's really simple. So the moment you build something, I think you will understand the simplicity and elegance of this protocol, and how it kind of anyone can just build it very simply. And getting into the protocol part, they support JSON RPC. And just for the ones who are curious, why JSON RPC? Why not the traditional RESTful API? RESTful APIs, as you know, are like we have a directed URL to a specific resource, and then you pass a payload. But in this case, given your server can do multiple things, and your server is accessible through one endpoint, it makes more sense where you would have one endpoint where that the one which LLM can connect to, and then the RPC is remote. If you don't know about this, like it's about you passing a method that needs to be run. It's like you have one endpoint, but the body is giving you the polymorphism of like doing multiple things, and then you're sending the body also. So that's how they can tackle your server can have multiple, they call it capabilities. Again, it's a very simple analogy to think about. So if you it's just API URL are like the old times where people get to hit to things like Postman browser or whatever. And now if LLM has to then hit these, that's what we call MCP tools. And the transport layer, again, you probably don't need to know the internals of it, but all you need to know is like that only two of them. And when to use what is like if you are developing something or a local like your desktop application, it's efficient to use STDIO. And if it's a remote server that your MCP is on the remote, it's best to use HTTP streaming. And core concepts. So this is where the tools part come in. All these three are called capabilities. Again, whenever you hear the word capabilities, just map them to these three. And one is, of course, again, I'll be using a lot of examples, so that analogies, so that you can kind of map it to the existing knowledge. So think of it as the web API get endpoint. So there is no side effect. All you're like reading from it. Again, the sources, you can use it to connect to your file systems or databases or whatever, where you don't expect any side effect. Whereas tools, on the other hand, is where you're posting something and it's executing some code and creating a side effect. So that is the difference between a resource and a tool. And a prompt again is a simple kind of, if you have seen in Agent Force, it's more about happy birthday to, and then there is a placeholder which LLM kind of fills it based on the conversation and all. So those are prompts. So these three are the current building blocks of MCP, and then you can write multiple endpoints using these three. So I'll quickly probably show some code. I feel again I would be showing very simple example. This is out in the online. And one of the SDKs I feel one of the popular ones is Spring AI to implement in Java. Again, I'm again coming to why this topic is named as Java. I forgot to say this in the initial state of the talk. I mean, I as a Java developer, I used to feel little, left out when there's a lot of things invested into Python to start with, right? And to me, and for a lot of developers like me, Java is not just language. Python language we can learn, but it's more about the ecosystem, right? The way we build things and the way we publish things, the way we test, automate, debug, all this. So a lot of, and even the IDEs that we use, everything changes. It's like it's not just mother tongue is not just a language. It's also about the region you live in and all that. It's similar to that. So I felt in the initial days of AI wave, I felt a little left out. But I'm very happy that Java is catching up. And then there are a lot of libraries and tools available in Java currently, which is kind of a 30-year-old language and ecosystem. But I'm super happy that we are having all these now to kind of play around with and have first-class support. And I felt Spring AI was one of the pioneer, and Spring, as we all know, he is like the big brother of all the frameworks. So it has all the integrations. But for if you're kind of a little adventurous, there are other great libraries also which are more focused. I mean, I would say Spring AI is more about it has integrations to a lot, and then because of that, it probably moves a little slower. That's my opinion. I'm not I don't have a parameter to say that, but then the kind of features, the way how they're catching up with the new happenings in MCP, I felt there are even other players. Like I would probably show in the website. You can check out more. This is what I love. I used it, but of course, this is on Kotlin, but it's a JVM ecosystem. Kotlin, I'll talk more about it. So this is one of the other library that you should really try out. And of course, MCP comes with its own Java SDK. So as you can see here, but that's like a vanilla SDK. I mean, I personally see this is like you only have those vanilla features, and there's a lot of things you need to stitch yourself. So I would personally you start with a framework like Spring AI, which has a lot of these written down. And then, if you're adventurous, go check out other ones out there. And coming to, I was showing the example. So again, like I was talking about tool right here, this tool is something which is trying to talk to a REST API and give you the weather information. And it takes two parameters, latitude, longitude. Now this function seems very familiar, obviously, because we are used to do it. But for LLM, no, it's not. You have to give more information to it. To be specific, MCP has a schema that you're supposed to supply. So you need to supply the schema in this format. Tool input schema, tool definition structure, which needs to have like the description of what your endpoint, what your tool is doing, and all the parameters that it needs to function, and description for each of the parameter, and whether it's required or not, and all that. And of course, Java SDK, the vanilla one I've shown you, maybe having some certain utilities to build this. And Spring AI, of course, given its ecosystem, has already kind of makes it easy for you. So you can, again, the annotation driven thing that Spring always had, you can use it, and then as if you can write comments, as if it's like you can annotate your functions descriptions on top of it. So, and then you can also give descriptions, like there's a tool param. I think this example doesn't have, but most of the times I think LLM would figure it out, given that there is this proper naming. But otherwise, you can help LLM saying, okay, I need latitude, longitude information. So when the user says, what is the weather here, or maybe you could also have a middle tool, maybe that this depends on, which figures out the latitude, longitude of the country of the user. So you can, one easy poor man's way of chaining tools here is like, you can say that, okay, before calling this tool, you can write in plain English, like before calling this tool, call the latitude, longitude tool to find the country of the user. And that figures out the country, and LLM then calls this tool with latitude, longitude, and calls it. I'm going to talk more about advanced ways of chaining and setting these tools in the form of graphs going forward, but I'm just giving a teaser of how it looks like. So I hope you got some idea. Again, like I said, it's very difficult in the given time that we explain or get into details. I want to cover the breadth of it so you can do it in your free time, explore more. So, and one more I forgot is of course, community-driven servers. You all know Salesforce itself has an AI hub, right? MCP Exchange. Wow, this keeps growing. The last time I checked, there were only 2 rows. I think they keep adding almost every week. Almost 2 or 3 tools come up. I think there is also a way you have built one yourself. You can submit it to be present in this exchange so other developers can use it. And of course, the guideline is to follow the security protocols and only to use the approved ones, because given this is a new space, right? It's not fully vetted. The security is there in MCP, but yeah, there are always vulnerabilities outside. And if you want to check out what is this awesome MCP servers, so this is another portal which is again pretty famous across the community, where you'll find everything in the wild. Right, there's so many you can kind of search and then play around. I would recommend even go into the GitHub, see the code, and unfortunately, most of them are written in Node.js and stuff, but I think you should be able to make out. Of course, we have cursor IDs and all. You can ask it to explain if it's not familiar. But yeah, you can always to play around. You can translate that to Java and then see, right? That's how you can quickly learn things. Now, that is that. Now, this weather service, I already just spoke about it. And another thing that I find very interesting, before MCP, there is this popular thing called RAG. I mean, RAG still exists, doesn't mean it's gone. But I kind of had the confusion. What is the difference between both? But it's like the fundamental difference is RAG is more about getting the right information, augmenting it to the context before sending it to MCP. And it can be coming from a vector database or file system, whatever. And MCP is that tool which provides it. It's just a standard that gives you that. Like, if you think about it, MCP is like one of the ways to achieve RAG. So essentially, they're not different concepts; they're complementary concepts, and you should probably use MCP, to kind of feed your LLM. And like I said, OpenAI already has an agents SDK before MCP. But the thing is, and the pattern is almost similar, but the only caveat is it's tied to OpenAI. But that said, after MCP got released and with this popularity, OpenAI is now embracing MCP, which is like a big endorsement, right? To if you are investing in learning MCP or building with MCP, you should be assured that MCP is gonna stay. Given such a big player is kind of ditching their own protocol and then adopting MCP. Right? That is the power of the MCP. And then you should also check out this A2A protocol. A2A is released by Google. And best part, again, they're not orthogonal. A2A loves MCP, and A2A operates at a level above MCP. MCP is close to the tools, and A2A kind of lets you orchestrate multiple MCP servers for multi-agent and all. I'm not going to go into details, but you can obviously read from the official website. here. So that's very interesting paradigm, how you can kind of build things on top of things. Um, so now I'll delve into, now that we understood kind of what is an MCP, what can we use? I mean, what can we build using it? And whatever I'm going to show you is not limited to MCP. MCP is like just one of the building blocks of building agentic flows. I might probably even show you the OpenAI's SDK examples. That said, the constructs are same. You can kind of just replace OpenAI and then just use MCP tools in place of it. And then configuration change is the only thing that's like, you don't have to change your tools and all. But the mental model is what makes me, excites me, because like unlike traditional examples where we had orchestrators all the while, right? We had orchestrators which used to orchestrate different components of a software application. But the orchestrators always had one driver, the user. Maybe it's like user inputs. That is the non-deterministic part of it. But here we have like two drivers and two non-deterministic drivers here, LLM and a human. From both sides, they kind of change the way it flows, right? That's the beauty of it. So that is where the traditional orchestration you kind of need to think differently when orchestrating AI tools, AI agents in AI agent thing. And then second thing that's interesting to me is like, now, as you bring in AI into your software application, it becomes like your super utility library. Like, let's say in old days, you want a sorting library, maybe you build in some Guava collections or something like that. Or you need some other library, you kind of search for something that's popular and then add that dependency to your software. Now, with LLM here, there's so many things you can do and depend on LLM. I'm going to show some examples that you would not have thought about. Maybe can we use LLM for that kind of thing? Where now this becomes your super utility library. And the part is it's about kind of recognizing the right pattern or right ways to use it, because the thing is, unlike your traditional library, it's not deterministic. It's always probabilistic. So it's important to use it in the right way such that your outcomes are deterministic. Of course, sometimes you need randomness, but most of the times in software applications, we always need that determinism. Like it always has to work the same way. Same as an output can be different, but the semantic of the output should be same. So that's how you kind of think about when you're bringing AI into your applications that you currently have. Those are the 2 points I would think kind of really help me think about the way we build it. And AI JVM, I spoke about it already. And the land graph. Now this is where we're going to the next level of having a bigger picture. But that said, here's a twist in the talk. My tech talk title does say land graph, but I had a change of mind because last Saturday, there is something else dropped in which kind of grabbed my attention. I felt, okay, LangGraph, again, like I said, I always had this gripe. It's Python based, and the LangGraph 4J, you find it's not like built or maintained by the LangGraph team itself. It's driven by community, open source community. So the features, you don't get like 1:2 parity immediately, or it kind of sometimes you compromise on it because it's not native, right? It's always like a port of something else. So you don't have the first class JVM support. So this is what I found over the weekend. I was contemplating until yesterday, should I like really switch the topic? But I felt it's injustice to not talk about it because it's really awesome. Like I said, again, the first principles, the constructs, the patterns are same. But the thing is how it's like close to JVM and it's driven by JetBrains. That's the promising part I see in this. The IntelliJ guys that we all use, of course, our favorite editor for Java development, and it has first-class JVM support. But only caveat, maybe if you're a Java developer, it's written in Kotlin. But Kotlin is something people say it's like does better Java, and you can pick up in like 7 days if you're a Java developer. It's very, very similar to Java, and it also has the interoperability with Java, as in you can have a Kotlin class and Java class next to each other, and they both can call each other. So, and then and then the best part, the reason why Kotlin and why not Java is, so most of this that I'm going to show you is like DSL, the domain specific language. So if you have worked with something like Gradle, it's like a build tool similar to Maven. Uh, DSL excels where you got to configure things like building a graph or a state machine or stuff like that, right? Java, unfortunately, as a language, is not as of now suitable for DSL programming. Not very easy. I'm not saying it's impossible, but it doesn't seem natural if you write a DSL in Java. Again, one more example is an XML. XML, like you have a certain structure, right? If you, let's say, try to build XML in Java, it just doesn't seem right. Even JSON, right? So, but in Kotlin, it's very kind of, I'll show you in a moment. And like I said, you shouldn't really worry about the learning curve. Like I said, it's in this case, it's only language. The ecosystem remains the same. The way we debug, the way we test, automate, everything, uh, and it's also like it has a lot of overlap with JVM. So you can literally write your prod code in Kotlin, test in JUnit, Java test. So that is the best part of it. And of course, it's a Google's first choice for Android apps. If you have seen it, if you are into Android development, you would know nobody uses Java these days in Android. It's all Kotlin. And it's multi-platform, which is exciting, as in you can write Kotlin and you can publish like a JavaScript application. Right, that comes really handy if you're doing something multi-plat. So again, I would leave you to kind of explore this more. This is the website, Kotlin website, and there's so much more written in here. But it's very Java-like, and the best part is they kind of, this is what I think of. Like maybe you have read this book called Effective Java. So so it's like if you learn Kotlin, you don't need to read that book, Effective Java. So they brought in all those best practices and embedded in the language. So that's what I would say. Now, what is Koog? Now, Koog is something that, again, like I said, JetBrains released very recently. And this is also a agentic framework to build AI agents. And you can kind of compare it with LangGraph. It has same constructs almost. So today, like I'm not going to go into the depth of how to do things, but we'll just talk about what are the things. And you can start with like a simple AI agent, simple API or AI agent. Simple API is like it's like you try, fire, and forget. So I'll take an example, like going back to my IDE. So imagine you want to play a guessing game with our LLM. So it's like you give a number and you kind of ask, sorry, you think of a number and you ask LLM to guess that number. LLM will give you some. Unfortunately, I cannot run this because my OpenAPI balance is out. The key doesn't work anymore. For you, for playing, I would recommend you set up something like Olama. It's a local LLM that you can run on your on laptop. I hope that we all have M3s, etc. So you should be able to run that locally. So you can play with free. If play, otherwise you got to pay some dollars on OpenAPI, because all of these applications I'm showing you need an OpenAPI key, or even a Google key, whatever it is. But anything that kind of you got to pay for them. Especially of course you can, for the MCP part, like I've shown earlier, you can just use cursor ID to kind of play. That's because it's free in Salesforce. But the moment you kind of write clients also in programs, that's when you kind of need to have a key. So you can again Google around and understand more about that part. There may be ways I have to explore more to do something for free. For what I found is Olama is the best, but even I have not set up. Mine is an old M1, so it kind of heats if I run it now. So That's it. But I'm going to show you what it is. So what it has is what you're feeding this LLM in this example is like a less than tool. And the funny part I see is earlier we used to write comments to make understand the code. Now the comments itself have become the code. It seems most of the code I see is in plain English in this application. Right? As the user if number is stick. So the guessing game is this. Like I'm telling the LLM to do certain things, like less than tool greater. When a user says that the number, he has some number in mind and says, okay, it's less than this. So you got to tell the LLM what it means when he says less than this. So you kind of describe your tool here. Similarly, greater than, and then propose number or whatever. And then you got to bind all these tools in a registry, in the tool registry. And then you kind of give a prompt to this LLM saying this is a guessing game, these are the steps, these are the rules of the game, etc. And then you run it. This is like a simple single run agent. And it kind of, it doesn't have branching if you think of it. It kind of goes back and forth and kind of does it. But it's just one agent, one tool that it can, or multiple tools, but one node. I'll get into the details later. But there are no steps. It's not like a multi-step process. So that is where a simple API agent comes handy. And I hope that kind of makes sense. I'll get into deeper examples, and let's say if we have time towards the end, we'll probably have Q&A and then see some more. That's why I'm kind of rushing through this. And now coming to the second part, the AI agent part, where this is where things get interesting. Think of like you want to bake a cake, right? That's let's say that's an example. Now that's a multi-step process. So multi-step process, how can you define this multi-step process? Forget about running it, but defining it is in the form of a graph, right? And again, this is very familiar. All the familiar part that we know, the graph. We probably have state machines, orchestrator graphs in our traditional orchestrators that we know of. It's only about how they are being kind of connected and then played is the difference, which makes it an AI agent versus a plain old orchestrator. So again, it's made of strategy graph, a subgraph. These are all common terminology you would find across frameworks. So a little bit of change maybe, but it's the same thing. You should be able to connect things. A subgraph, so it's like you have a big graph, and then graphel is made of subgraphs, and subgraphs are made of edges, nodes, and tools, and it can also have more subgraphs. So that's kind of a recursive thing that you would find. And we'll now understand with analogy what is what. Now, subgraph, strategy graph is like, as I said, probably you're trying to bake a cake and you have a recipe. That's a strategy. You have a goal. And the subgraph is a detailed procedure of a specific part, like making the batter for the cake or frosting or whatever, which again have probably multiple steps, which may not be simple, which has specific steps. And the nodes are individual steps. Again, you may have step one, do this, step two, do that, etc. So think of it like, I hope you got the analogy. You would have steps, and some steps may be complex, which become subgraphs. And it just is the sequence, as in, obviously you can't start with keep things in oven. You got to have the raw materials to do it. So again, like a same old edges. So how nodes are connected through a sequence of steps and how they're interdependent on each other. That is the part of edges. And tools, the actual equipment or services used to perform a step. This is an interesting analogy, right? Like maybe you kind of think tools and edges are similar. Nodes are like, they kind of sound similar, but it's more like tools are functions that agents can use to perform specific tasks. It has a name, description, parameters, etc. So, and they get registered in a tool registry. Nodes, on the other hand, are like fundamental building blocks, like I said, in a workflow. And if you think about nodes versus tools, nodes are like steps in a recipe. And tools are like probably the ones you use to chop vegetables or whatever that, let's say you're cooking and you need a knife. In this case, maybe you need an API call or you need a database. And tool is closer to the real world, when I say real world, I meant to say those traditional databases, etc. So I hope that kind of gave some idea. And now let's build a calculator app. This would, I mean, I would probably think this is the last thing I would use an LLM for, because calculators exist even before I'm born. But there is a clever way you can use calculator. You can kind of use LLM to do your calculations. Let's check it out. So imagine you have your calculator tools. Most of us must have learned programming with a calculator app. I did the same. So you have your plus, minus, etc., and then you have your expression like this. Now, how would you use LLM to efficiently do it? Of course, you can write a program to kind of, if I have to calculate this in parallel, like every bracket I can calculate in parallel, and then I can join all the results together to get the result, right? That's what a traditional programmer would do, the ones which are born before the AI era. But it's like I said, this is a super utility. So this is now use it. Like in this case, what we're doing is, I have a tool registry. I have given all the calculator tools. Each tool kind of has a proper description. What is what? It adds two numbers, first number. So again, imagine you're feeding it to LLM. This is how you add numbers. Like I said, always some LLM. Maybe it's, again, you can't say every LLM is equally smart. You might think, okay, can't it understand how can it add numbers? The misconception is we all think LLM sit there with all the algorithms in their head, right? That's not true. And it depends on the capability of LLM. Let's say if you're hitting that open ChatGPT, Gemini, they have sophisticated LLMs. They can be LLMs which are really naive and only not trained in all the data. And it's always important, if you are looking for deterministic outputs, that you feed the right context to LLM properly. Like if you have a deterministic algorithm, again, I'm saying you have parts of it. Orchestrating part, it can kind of figure it out. So now we're feeding it, saying this is plus, this is minus, etc. And I'm saying you should calculate me and give me the results. And then here, what I'm doing is, again, this is a framework specific part that you kind of probably, for now, what you need to understand is there are some built-in nodes in the framework that you don't have to, again, write it yourself. So here is a strategy. Your strategy is like evaluate my expression. Just a name, it doesn't really change anything. And internally, I have multiple edges and nodes here. And let's check out how they are connected to each other. First of all, let's check out what are the nodes. So there is a node called LLM node execute tool, multiple send tool results, and compress history. I'm going to talk about compress history later. But what this example is trying to do is it's trying to call LLM, chopping your request into multiple things, and then it's executing in parallel. Again, you could go read the description of it. Here it says it can execute in parallel. So, and then it can send the results back in parallel, and those results can be kind of compressed. And the way they are connected together, again, this is the beautiful part. See how the DSL feels so natural. Doing the same thing in Java, unfortunately, is not as fluent as it seems that you see this in the IDE. So that's, I feel, is the best of both worlds. I am in JVM ecosystem, and I'm also having a language which has a beautiful DSL. So, and then you're connecting kind of these edges one after the other. So this is how you say one thing comes after the other. So how you connect things, and then if you're also saying that, let's say during this conversation, if the history size has increased, here, of course, the currency is tokens when we are dealing with LLMs. The moment you start getting the bill, you'll realize how painful it is. It's unlike other tools, it's not free to play with. So you got to be mindful about the tokens you're using. So it also, the Koog framework has a inbuilt node to compress the history every now and then if it's above certain 100. So it's like, think of it like an intermediary edge, right? So it's not one in a sequence, but you always kind of, this is always monitoring the history and then kind of compressing it whenever it reaches a certain amount. That's why we call it a graph and not like a chain. And you get a result, right? So again, like I said, if you want to, I'll point out this GitHub. Maybe if I've not shown earlier, you should click on this. You should go to the GitHub, and then you can kind of just pull in this repo. Given if you are already using IntelliJ, you should have all the plugins inbuilt, and you should be able to build it. And come here and then change this OpenAPI key to point to yours to play around this example. Now, the subgraphs, like I said, this is where we are making the agent a little more complicated by having those small little galaxies within galaxies kind of thing, and processing within an agent strategy. Now we'll again talk about a quick example, going into a banking example. Now let's build a banking agent, and so the banking agent. Yeah. So the thing we are building here is so there can be two kinds of requests. Somebody is trying to transact with the bank, like send that 25 to euros to something or $25 to some other account or something like that, or somebody is kind of analyzing in the sense provide transaction overview, what is my statement, etc. So that's analytics. So the way it's done here is, again, you have two subgraphs, transfer money and transaction analysis, which internally orchestrate a list of tools. If I go into money transfer tool, there is, from the description, again, you can understand everything, the send money, and then the get contacts and all this. These are all transactions, right? You're transacting your contacts and all this. I think there's some sample transactions for you to understand better. Similarly, analytic tools are analytic tools are calculate the sum of I think what did I spend for what, how much of the spent into this kind of, you're kind of getting statistics over your spends. So that's the transactional part of it. Now you have two complex, I would say, complex tasks of their own, which need a subgraph of their own. So that's where we kind of get back to, yes. So we have transfer money, transaction analysis, and then we also have a classify request. So how do, when somebody gives a prompt, you need to classify whether it's a transfer request or analytical request. So that itself, that you kind of are forking in two things. And remember, at any point after transaction, you kind of want to just go jump into analytics, right? Because this is user non-deterministic, and that's where the complexity comes in. And that's where imagine doing all of this with a traditional orchestrator without LLM in the scene. And that becomes super difficult. And here we have achieved it like less than 200 lines of code. If you combine this, that won't even go about 500. Right? Imagine once upon a time there were applications built by teams on things like this. So that is the best part of using LLM and then trying to orchestrate things for you. So essentially, what this banking application does is, when a node start, you classify the request, and when classify the request, you forward to transfer money if it is of type transfer. And who decides this? LLM decides this on its own. This condition, LLM kind of gives or annotates the request type based on plain English that a user sends. So we are just feeding this if condition and nothing else. And then classify request, and then this, if it's transaction analytics go into this graph. And this graph, of course, if the result comes, you just finish it. And within this graph, as I said, there are multiple tools. Like I said, a subgraph can be made of multiple tools, multiple subgraphs also, which can kind of is even more complicated example. I would probably leave it to you. There should be somewhere again. I think here is one example that you can see how we can go. In the interest of time, I'm kind of not getting into that. And agent memory, this is another fascinating thing. While we transact, how do we make our application intelligent? One of the ways is, of course, we need to store memory. And this again, very different from the traditional way of how we cache things or put things in memory, right? Of course, we store things somewhere. That is the same part. But the way we store is not like, okay, you have a map, you do a dot put of some key and value. Instead, I'll show an example. Let's build a customer support agent. Mm. So this customer support agent, let's see what we are asking it to do. So there's a user preference concept. While a user is talking, what we're instructing this is uh, track what is the communication style of the user, and what is the terminology he's using. What are the personal preferences, maybe even the language or whatever, right? And then we're feeding it like an English, just like a description to, again, no if else conditions, nothing. and and we're also giving it a tool to save it. So again, here it comes from the framework, which is this is the saving part, save memory. The certain way you do how you achieve it, but again, like I said, the concept is important. And they're storing it to a file system in a JSON format. And we're clearly giving the way we have to store this. But the part we need to understand is, so we have a save memory which is happening on the run while the conversation is happening with the user. And we are, of course, embedding it into our graph like this. So when a session starts, what we are asking is load memory, load from a previous preferences that you have stored for the user. So you can have that conversation. Like if he is super casual, probably you want to have a casual conversation, or if he's strict, maybe you should probably not crack jokes with him. And then you start the support session, ask his queries, do whatever it is, and retrieve results, like maybe his cases or whatever. And then after it's done, again save to memory. When I say then, it's not done, but it's all a part of graph. Again, the thing is not see this as chain, but a graph, because LLM orchestrates it. So that is the kind of things that you can build, because now you also in the framework have something where you can store things and then use them back in the conversation. And some more awesome features, history compression, we have talked about it. And vector embeddings are also supported. Yeah, I'm not going into depth, but it's all about how you store those large. You can generate text, right? You can ask probably, hey, write a program for insertion sort, or store this program and then ask it back with the similar English. So vector, as you probably know, vectors are the databases for LLMs. So you got to store, and then they're stored based on the similarity index, etc. So like things kind of flock together, and then that's how LLM kinds of finds things easily. And all of this is there's like in the framework there is kind of a very exhaustive testing framework, which is, in my opinion, very, very important to start any application production grade. So they have ways to automate. It's not easy to automate these applications, not like traditional applications. So there are ways to do it. I am not diving in depth into it, but there should be examples that you can play around with. It's mostly about mocking an LLM. Again, this is another way. I think if you don't have a token, maybe you can try this, although it's not very fun because you're playing both the roles here, both LLM and the user. But again, to see things in action, debug things and how things are flowing, you can probably try writing a test for yourself and then trying these examples. And we have already seen a lot of examples, like there are many more in here. And I would also probably suggest you go check out the LangChain 4J as well. LangChain is very popular. I have no doubt about it. But I have some kind of gripes on LangChain 4J. 4J is for Java. But that's also an awesome thing. And whatever we just spoke, right, you should be able to find all the similar concepts there as well, how you graph, create a graph of nodes and stuff like that. And that's it. Thank you very much. I would love to take any Q&As if you have.
Hi Gopal, there are some questions in the chat. Please check on that.
Okay. Oh, so many questions.
Hey, hi
How do I
Gopal.
pick one?
Krishan this side, Gopal.
Hey,
I have
Krishnan, hi.
a couple of questions. One is I see there are two ways to build AI systems inside the Salesforce. One is
Mm,
if we wanted to leverage the planning and execution, we wanted to build the agent, right? We can leverage the agent force capability, and we
mm,
can use another way is if we wanted to go with third party tools like Cloud and Cursor, we if we wanted to use their power of the inner loop cycle,
mm,
where they understand they have inbuilt LLM and all, right? We can
mm,
give quantify MCPs, right? So
mm,
is there any use cases in Salesforce where I can use this third party like let's say LangChain or Llama Index or Hashtag to
mm.
build some content ship it bypassing the agent force?
Yeah, good question. So Agentforce themselves has their own planner service. Again, I cannot comment completely. I don't have a lot of expertise. But whatever in the end, whatever we are trying to do is okay. We have certain things to do, and we want to orchestrate them with LLM in place. And there are multiple ways to achieve it. Of course, Agentforce has the pattern, a very similar pattern, where we feed the capabilities to Agentforce, and then that orchestrate things. Now, this is another where if you want to build using, as in you want to build custom AI agents outside of the ecosystem. But of course, you can plug them because given, as you could see, I'm able to use Open API key. And I'm sure we should have some way to tap into the LLM agent force users. But that's it. Maybe in this case, I may be at loss given I bought a license, but I'm not using the planning service and all those services. And I'm writing my own. I hope you kind of got what I'm trying to say. Did that answer your question?
Yeah, I was just thinking like, can I build my own agent and ship it through Salesforce? I mean, is that
With Salesforce, yeah, and yeah, I need to check and get back to you if we can plug this. Like I said, maybe if you're doing it yourself, Agentforce may just act like any other LLM. Maybe it's like if maybe because there's also cost associated to using an LLM. I think that is where Agentforce license that you bought, that return on investment comes back. But if they're already also like simplifying the orchestration for you, I would, if I'm an agent force developer, probably would use their patterns over writing my own.
yeah? Okay,
But yeah, but on the contrary, I would probably compare what of agent force offers versus what's outside. Can I do more? In this case, I mean, we shouldn't limit ourselves if there is more to it. But like I said, I'm not an expert there, so I can't compare and tell you.
sure, sure. Yeah, it
Yeah,
answers. Thank you.
thanks. There's so many questions. I Unfortunately there is no Gemini integration here that I can pick up some interesting ones. So, but feel free to kind of speak up. I would copy all of this now. I think I'll try to respond to everyone if possible on Slack. But given we have like 6 more minutes, I can take up a couple more questions. Yep, sure. Yes.
Yeah, I just wanted to call out a couple of things. First of all, love the session. Great
Thanks.
introduction. I'm relatively new to building agents per se, but this really gave me a good mental model and understanding about how to go about that. Just wanted to confirm on one thing. Love the Koog calculator example. I is that I mean, from what I saw in the code, it doesn't look like it's actually making an LLM call per se, right? So I think the way I want to say it is, it kind of gave me a good idea of how to represent an existing workflow into a graph built of edges and things like that. Is that the right way to look at it?
No, I do see it's making a call. Let me quickly pull it up. So you see there's this executor. Let me see how it's used. So here is an agent. So agent takes these 4 arguments: executor, strategy, and the tool registry, and the agent config, of course. And executor is what makes use of the LLM. So it's a simple open API executor, and you're feeding all the tools into it. Does that answer your question?
Understood. So you are
Okay.
basically augmenting what we are building along with the existing LLM, right? In that case.
Correct. Right. We are telling
Got
it how to do a plus minus and all that, and then
it.
kind of leveraging it to do a calculation. Yeah.
Great. Sounds good.
Yes, Siddhant.
Yeah, hey Gopal, great session. I really wanted to know what line graph and all, and thanks on initiating that. I will definitely go online and check more stuff about this. So it's a conceptual question here. Whatever have you have explained in this course currently, so it felt more like these are fixed flow paths that we have for our agents. And from my understanding, I think AI agent is more about if we don't have a fixed path, it's more about a variable path that we would say that is an AI agent. So is Lang graph is capable on that terms also, or it's more towards the AI workflow automation type of thing that we are trying to provide some fixed paths to it, and it will definitely do those fixed path tasks and then accordingly give the output to the user, or it can achieve those complex scenarios also. Let's say for coding itself, we can say if we want to create an app and all. So there are multiple iterations that will happen because of all the issues that come up.
Hmm.
So yeah, just want to ask, is that also a thing, Lang graph?
So if I understand your question right, I think from what we have discussed, what you're referring to as fixed path is the graph that we have defined. Is it right?
Yeah.
Yeah. So think of it this way: we are the playground is fixed, but how do we jump from one place to another is not fixed. That's driven by one end by the user, other end by the LLM, right? So it's not exactly fixed path, but of course there are, of course, I like Gemini like agents may be like they are like the ground may be bigger. They can play. They can go like if you suddenly ask a different question. One new question you can ask about cricket. Rather, next question you can ask about like weather or whatever. But let's say if you are building some serious application, a focused one, a bespoke one, you kind of, and again, whatever I've shown are just examples. But imagine a team's building large graphs, right? That will probably kind of give you that illusion that this is like variables. That's the answer your question.
Does it come back for the feedback from human again? Because if I'm
Yeah, it
talking,
does. It does. It does. That's the part. If you see the examples, so there is always the ask user part, and then there is this the AI execution. So this guy, whatever application, it sits in between. So it gets responses from the LLM, it gets requests from the user, and then based on this, it needs to now make a decision or plan his next step. Its next step. So that is how. So we are in the adjacent nodes. We're just giving it that nudge that okay, if this is it went wrong, I think you should probably go there and then check it.
okay,
But we are not writing any if else conditions there. That's the part of it. Yeah. Was
yeah,
I clear?
yeah, sure. Thanks.
Yeah. Okay. We are almost on time. Prabjot, let me know. Is that okay? We extend or should we take these questions offline?
Prabjot is not available, so yes,
Okay.
we can take these questions like 2 more people.
Okay. Yeah. Please go ahead.
Mohit
I think
or
next one is Mohit. Yeah.
Yeah, hi Gopal. Great session. Loved the code that you showed. So I actually just had a question. Like I was trying to build something using LangGraph and just wanted to understand. Let's say we I mean, it's good like we are starting with maybe 7, 8 tools, but let's say if we had maybe more than like 50, 100 tools. So it
Mhm.
might happen that the LLM might not hallucinate, but it might not be able to figure out the right tool. So
Yeah.
there either we can add the system prompt, or I mean, have you tried like the capability like where the output of one tool can decide the next tool better than the
Mhm.
system prompt? I mean, obviously
Yeah.
changing the system prompt is also a bigger problem because we loses the control. I mean, it's
Mhm.
not backward compatible kind of thing, right? Like if we change the
Mhm.
prompt, it might not follow the path which it followed previously.
Mhm.
So just wanted to understand like what's your thought on that?
Yeah. That's a interesting problem when we have these 100 different tools. We had a similar challenge as well recently. What I would suggest, of course, is subgraphs is one way. Group them. The like ones have to be grouped together. And this is my opinion, as in the tools, right? They, of course, we need them in a fine-grained manner, but sometimes we probably don't need a tool for each. As in, we don't need a node for each API or something like each database call, every query or whatever, right? Sometimes, I mean, we got to. Okay, I'm losing the room. I think I'll maybe we can get in touch in kind of offline, and then I can
So
answer those questions if that's okay.
yeah,
Thank
definitely.
you.
I'll thank you.
Yeah. Thanks everyone for joining today. Have a good day. Bye-bye.
Thank you, Gopal, for the wonderful session.
Thank you.
Yep.
Gopal.
Thanks.
And
Thank
sorry
you.
for not taking the questions. So in the chat, we have the feedback form and the intake form. If you are interested to give your own tech talk, so you can fill the form. And please do give the feedback as well. Yes. So both links are available in the chat.